Right, let's do this. Okay. Just a reminder, I do watch the Discord lecture chat here. If you want to, if you don't want to use it, fine. But if you see me looking at my phone, I'm not ignoring everybody. I'm just looking at chat, and I'll answer questions that go there, etc. This is less relevant in 312 than it is in 116. But the course website, I combined Wednesday's and today's slides together. And if you refresh, if you still see slides there, if you refresh, it'll disappear. But you already had access to those slides anyway, so it doesn't really matter. But I'll just present from the slides for today on the schedule. And those are, the good bits of Wednesday's slides. I just combined into these, just so we can keep things a little more organized since I covered these slides. Actually, I should have moved these slides down to Wednesday. But I want to start with a quick demo. So we have homework 1 is upon us. And by the end of today, we're going to learn how to do objective 1 of the homework. We won't know how to do the Docker setup. We're going to table that discussion for now. But after today's lecture, this is when you could get learning objective 1 complete. You'll have everything that you need to know from me to be able to get this one done, aside from the Docker setup. You wouldn't be able to get credit yet because you have to have Docker setup. But in the slides, I'm going to talk to you about the theory behind it. So I do want to get, I do want to get some practical stuff out there. So let's talk a little bit of code. So I have an example here of a Python server, which is going to look similar to what your homework code should look like. If you're doing Python, like I said on day 1, I will do most of my examples in Python. I'll kind of assume that most of you are going to do Python. If you want to use any language at all, I shouldn't say that because somebody's going to come up with something crazy. But if you want to use any language, that's fine. You can use whatever you want. But the course will kind of officially support Python. Python will be the language of choice, at least for my lecture examples. The course really focuses on concepts and protocols, so language is less important. And in my opinion, and in most students' opinions who take the course, Python is the language that gets the least in your way. Other languages will have some things that are just tricky to do, and you end up fighting with the language more than focusing on the concepts and the protocols, which I want to focus on the concepts and the protocols. So if we use Python and Python just kind of plays nice with us, that's the preferred way of doing things. So this is the kind of a basic setup of how you can organize your code, or how you can initially set up your code. It is using socket server. This is the recommended TCP library that you can use for Python. I'll even go as far as to say you should use this. Use socket server. There is also, if you just Google Python TCP server, you might also get just the socket, where it starts with import socket, and you deal with the sockets directly. I do not recommend using that. If you're using that, if you're starting your homework early and you started using that, I highly recommend switching to socket server. It's going to use the same stuff. It's going to use socket underneath. If you look at the source code for socket server, it imports socket and then adds extra functionality on top of that. So it does more for you that you don't have to worry about. And in this course, we don't want to worry about TCP IP at all. The slides that we saw on Wednesday, we don't want to think about any of that. We just want to use that stuff. Socket server is going to be our TCP server. It's going to do three-way handshakes. It's going to do sequencing of packets. It's going to create the IP packet. It's going to do all that stuff for us. It's going to do everything that we talked about on Wednesday for us. So we get to focus on what we want to focus on, and that's web applications, which starts with HTTP, which is the big topic for today. So socket server does everything else for you. If you want to ignore that advice and use sockets, I'll give you import socket. I'll give you a word of caution. It'll be fine for the first 2 homeworks. And then when we get to homework 3, where we need simultaneous connections, doing multi-threading with socket is really difficult. Doing multi-threading with socket server is trivial. It's absolutely trivial. So that's where it'll catch up to is homework 3 if you build around socket instead of socket server. So just use socket server now, and you won't have to worry about it in homework 3. So the way this works, we're going to specify a host and a port. Host, use 0.0.0.0. This is pretty much localhost if you've done web development before. This is localhost as your host. It means this is going to run on this machine, and I'm only going to access it from this machine and not worry about actual networked connections. 0.0.0.0 for anyone who knows about localhost and everything. We're using this instead of localhost because it plays nice with Docker. If we use localhost, it won't play nice with Docker, and you won't be able to access your app when you run it in a Docker container, is the difference there. Port, this can be any number you choose. When we do set up Docker, if you've read through the homework document, when we set up Docker and Docker Compose, the port has to be 8080. The port that you choose here in your code itself can be whatever port you want. I'm just choosing 8000. Just a common port that we use for development, 8000, 8080, anything in the 8000 range really are common development ports that we can use. Port relating to TCP connections. So this will create a socket TCP server. This word threading right here is kind of optional, but that's what does the magic multi-threading. If we do threading, we're going to have simultaneous connections, no problem. We literally just add that word and use a different class, and everything works the same. But we're going to create our TCP server. It's going to listen for connections on localhost port 8000. So we're going to use port 8000 as our TCP connections port, and that's where we're going to listen for client connections. So our host, which is our IP, our port, which is our TCP, that configuration's here, and then the library just does everything else for us. We don't have to think about it after that. So we set up our server and tell it to run, and it takes a TCP handler, which if you haven't seen inheritance in Python, this is inheritance. I'm going to create a class called myTCPHandler, which extends socketserver.baseRequestHandler. And then I'm going to override the handle method. And this method is going to be called whenever you have a new TCP connection. You get a TCP connection, socket server says, I'm going to call your handle method. Here's the connection. Do whatever you're going to do with it. So we have access to self, which is an instance of the myTCP handler, which was created by the socket server. And that's going to have all the useful information, all the nice state and behavior that we want. All the information, its variables, and some methods that we can call, which we'll see in a second. It has a request variable with a receive method. This is going to receive bytes of information from the TCP socket. So remember, this is called after a client connects. The three-way handshake already happened, all that. And when they send us a message over the TCP connection, and all of the sequencing numbers and the requesting resends if we have drop packets, the reassembling of the sequencing number. After all that happens, this receive method is going to say, all right, I got some data for you. And it's going to return that data. Before data is ready, this method just hangs. It's going to sit here and wait until the client sends us a message and then return it. So this is how we're going to get a message from our clients. And this received data is going to be whatever they sent us in bytes. And then it's up to us to do something with that to make sense of it. So the client sent us a message. We're going to do something to it. For this purpose, for this example, I'm just showing you how to set up your initial code. So I'm just printing a bunch of stuff to the screen. And then we're going to use this request.sendAll method to send information back to the client. I'm going to completely ignore what they said to me, and I'm just always going to respond with, hello. And I need to send that as bytes, so I'm going to encode it. Monday's lecture, we'll talk about the bytes a lot more. But I'm going to encode the string into bytes. And if I want to read this data as a string, since it's bytes, I can do decode and read it as a string. Actually, since I mentioned it, I'm going to do both. And then I can run this thing. Oh, I minimize my console. How do I get back to it? Terminal. All right, and I'm going to run this. I'm going to do Python 3 Server 1 is where I have this code. And I'm going to run that server. And when I run it, nothing happens. Which is exactly what a server should do. Nothing. It just sits there and waits for requests. To send a request to my server, and you just saw that was the entirety of the program. That's the entirety of the code that I just showed that I'm running. To actually use my TCP server, I'm going to use my browser as the client. We just set up effectively a web server. It's not a very interesting web server, but we just set up our first web server, and I can access it using web technologies like a browser. So if I go to localhost, port 8000 as my URL, as my Siri, shut up. Don't want you. Localhost :8000 to type the URL. It's going to assume I mean HTTP, so I don't have to do HTTP:// though I could if I wanted to. Localhost, or alternately 0000 is my IP address. :8000, that's the port that I'm running my server on, so I want to connect with that TCP port. And then I'm not going to add any path, I'm just going to connect to the root path. And it says hello. And if I go back into my code, I can see what I get printed out. Let me get the code on here too. So first, I'm printing out the client ID, which I'm taking the client's host name and the client's port number and saying this client is sending data. And I can see, if I scroll up enough, this is my client host and port. I can see my browser chose port 58,232. That's the IP port that my browser is using. If you ever wondered how you can have multiple tabs open, for those of you who, this will make sense to everyone later, but for those of you, which can I assume most of you know this, web browsers work on port 80 for HTTP and 443 for HTTPS. Those are like the web ports. Those are the ports that we use for the internet. But if we're using port 80 and 443 for everything, how can we have multiple tabs open? It's because those ports are used by the web server. The servers will listen on those ports. But when we as clients connect to those servers, each tab is going to get a different port number and connect over that port. So when we receive messages, if I get a response, I get TCP messages over port 58232, I know that that's from this server because that's the port that I chose, that my browser chose for that specific tab. You can even have multiple ports for a single tab, for what it's worth. So this port, localhost, this port is sending me data. I got 599 bytes of data, and when I print that data, it's going to be print as a byte array. Most importantly for, oops, if I can do this right. Most importantly for today's lecture, the thing we're going to see today is new line characters are encoded as /r/n. So this is the request that we just got in bytes. This is what the browser sent to us. I'm also decoding it to convert from a byte array to a string, and then get it in a more human-readable format with the actual line breaks shown. And we can see that this is what the browser sent to us. We got all of this information sent to us from the browser. And then when we responded with something like this. Sent that as bytes back to the client, and the browser knew to read all of that and say, oh, you're saying hello, and just effectively display hello on the browser. So what we want to do is figure out how all that works. There were a lot of details there that I didn't talk about at all, because that's the slides job. Any questions on that real quick? Anybody trying to set up their socket server and run into issues? You got quick questions? If not, we're going right into slides. Are we allowed to post it in here? Oh, does he post the? I don't post the examples anywhere. Yeah, and don't post them in here. I don't distribute code for this class electronically because then I have in the past, and then I just see that code copy and pasted in I shouldn't say everybody's, but in a lot of students' code. And it's especially irritating when they show up to office hours with my code pasted, and then they say it doesn't work. Why doesn't it work? And it's because they pasted the code without even attempting to understand it. I want you to understand it, type it up yourself, and really go through the process of knowing what that code is that's in your homework assignment. If you don't understand the code that's in your submission, that's bad. It's not a way to learn. So I don't distribute code electronically. That said, you can always watch the video and copy it character for character. I can't really stop you from that. The only way I can stop you from doing that is by not showing any code examples in lecture, and I don't want to hinder everybody because some students will do that. Will you be able to get help in office hours if you use a language like JavaScript? Yeah, the short answer is yes. The longer answer is maybe. So the longer answer to that is, in office hours, even if you're using Python, we're not necessarily going to help you with coding issues specifically. We'll happily help you with the concepts. This course, like I said, it's about the concepts, it's about the protocols. It's not necessarily about the code, but just naturally ends up being about the code on the homework and the projects. Ultimately, at the end of the day, your jobs are going to be to write code for companies or your own startups or whatever. We produce code as software engineers. But I want to focus on the concepts and the protocols. So we'll happily help you with the concepts and protocols and any of the course material in office hours. We won't necessarily help you debug your programming issues. It's a 300 level CSE class. We just assume that you can code. Yes, I know sometimes that assumption is false. It's incorrect. But we assume, that's on you. If you got this far and you don't know how to use Python or use JavaScript or assemble a few lines of code, that's on you. That said, we might help you with your coding questions, but I do tell the TAs that they are not obligated to help you with your coding questions. I'll usually help with coding questions in my office hours, depending on exactly what the question is. Especially if it's something specific to the course that you just haven't had to code in any other course leading up to this point. I'll happily help you with those questions. But if a TA says, "Nah, I'm not helping you with your coding question," you can't get mad at them. You can come get mad at me and complain to me about it. The TA didn't help me, but I do tell the TAs that they don't have to help you with your coding questions. Yeah, go ahead.
When people struggle in this class, like previously, is it more so they don't understand the concept or that they don't know how to code it?
That's a tough question to answer. So the question is, when students struggle in the class, is it because they can't, they struggle with the concepts or because they struggle coding the concepts? It's hard to give a general answer to that. I'll give the cop-out answer of it's both. I think it's more the concepts. I'll take a shot at this. A lot of this is speculation, what I'm about to say. But I think students misunderstand the concept. Students who struggle, I think they misunderstand the concepts, at least to some degree, but they want to just dive right into the code. And they take that misunderstanding with them to the code. And then they code up the wrong thing, and they don't know why it doesn't work because they didn't take the time to study the concept before jumping to the code. Especially students who they'll skip lectures or don't pay attention during lectures, and they just want to jump to the code and get the homework done without understanding how HTTP works, for example. That's a great way to struggle in the course. But every student's different, so it's a lot of speculation and generalization. Every student is going to have different issues. Or zero issues. I shouldn't say issues like that. Maybe the TAs can give good answers to that too. All right, let's talk about HTTP. So let's talk about IP and TCP. So we saw IP, that's how anything moves through the internet. If data's moving through the internet, with an exception that a student talked to me about after lecture yesterday. There are some exceptions, but if data's moving through the internet, potentially, it's debatable. And we debated for a little bit, it was fun. If data's moving through the internet, it's using IP. That's how we get things moved around in the internet, but it's unreliable. TCP adds reliability, so when we send messages to our clients send messages to our servers, TCP says you're going to get your messages. So what do we do with that? We can communicate reliably over the internet to any device that's connected to the internet. around the whole world. What do we do with that? And the answer, our answer for this class is HTTP. Something I'm positive you've heard of a billion times, but we're going to crack it open and see exactly what it is. Like all semester. You're going to be sick of HTTP. Any questions about HTTP? The de facto answer, the answer to all of them is in RFC 2616. This is linked on the course website, along with whenever we cover a new protocol. HTTP is a protocol, by the way. Whenever we cover a new protocol, I'll link the official documentation on the course website. The RFCs are the answer to all questions related to these web protocols that we're going to see, most of them, except with the exception of WebRTC, I guess. It doesn't have an RFC. But HTTP does, and RFC 2616, everything that is HTTP is in there. We're specifically talking about sections 4, 5, and 6. So if you review those sections of the official documentation, you'll have all the answers. You'll know everything there is to know about HTTP. Even if my slides or my presentation, anything I say, which this shouldn't happen, disagrees with the RFC wins. The RFC is the answer. So whenever, bless you. So whenever you have in-depth questions, especially if you have a question in lecture and I don't have an answer, I say you hit the wall of my knowledge and everything. Your answer is going to probably be in there if it's related to HTTP, at least version 1.1. And everyone follows those. Well, everyone's supposed to follow those. So if every browser developer, every web app developer, we're all coding according to RFC 2616, communication should be able to happen effectively. So this is an application layer protocol as opposed to our IP and TCP, which I'm not going to try to remember all the layer names, but a lot of you probably know them, especially if you took modern networking concepts. You've dealt with the network stack a lot. This is an application layer protocol, which means that our applications that we write care about HTTP, where they don't necessarily care about TCP, and they almost certainly don't care about IP. Any web app that you're going to write doesn't care about those protocols to an extent. But HTTP, our code definitely worries about them. Worries about HTTP, and our code has to speak HTTP. We can use our library for TCP. TCP can use probably other libraries for IP or our operating system itself for IP, but we have to code HTTP at the application level. So let's learn what this thing is. So this is a request response protocol, meaning our servers don't do anything unless they get a request. So when I first ran that code, it didn't do anything. It just sat there, just humming along, sitting there, until I went to the browser and sent it a request. Once I sent the request, then the web server responds with a response. So we have HTTP request and an HTTP response. And that's how we do everything with HTTP. We can't do anything unless we get a request. We get a request, we send one response, and that's it. So if we write our server to speak so-to-so, we implement HTTP, then HTTP clients can send us requests, and we're going to respond with those responses. And anything, I'm saying client and server, front end and back end, I briefly defined on Monday. Anything on the client side, the code sending the requests, that's going to be front end or client side code. That includes anything that we send in a response. So if we're going to send HTML, we're going to send CSS, we're going to send JavaScript, we're going to send multimedia. All of that is considered front end. Once it leaves the server, that's front end stuff. The back end is our server. That's what's sending the responses, what's reading the requests, sending the responses. That's everything that's not sent to the client. So any code that's running that wasn't sent to the client, in the example I showed, like all of that code, that was back-end code. None of it was sent to the client. The only thing that was sent to the client, which would be considered front-end of that example, are the 5 characters, hello. That's it. That was the whole front end. It wasn't a very interesting site. Not a very interesting site you would want to visit. It was all back-end. Back-end, like I mentioned on Monday, back-end is what we'll focus on in this course. So to load a website, The client is going to send us multiple requests. For our purposes, web apps, our client's almost always going to be a browser, except during testing, I should say. The browser is going to send an HTTP request for the HTML. Our server is going to get that request and send a response. We only get one shot at a response, so we get a request for the HTML, we send a response with the HTML, end of story. But I think I can safely say you all know, right? You all know that a website is more than just HTML. It's going to be CSS, JavaScript, any images, anything else that also needs to be loaded on that page. So the front end is going to get, the client is going to get that HTML, parse through the HTML, and read that for anything else that needs to be requested. And it's going to send a separate request for every piece of thing. I lost that sentence. Everything else that it needs. So it's going to send another request for the CSS, another request for the JavaScript, another request for an image of a cow, another request for another image. And it's going to send a bunch of requests out, usually multiple JavaScript files, multiple CSS files sometimes. If you go into your browser console, which is something I haven't showed off yet, but if you go into your browser console and visit any modern web page and look at all the requests that are being sent, you'll have dozens of requests being sent to load a single web page. So it's a request response protocol. We can only respond to a request with one thing, but we'll handle many requests for the same client just for a single page load. So we'll host our CSS separately. We'll wait for a request. Hey, give me your CSS, and we'll respond with the CSS. Hey, give me your JavaScript, we'll respond with the JavaScript. Hey, give me this image, we'll respond with the image. But they're all separate requests and responses. We're going to talk about two different types of HTTP, at least to begin with, until actually just next week or the week after. Next week's a lot of Docker. I think it's at week 3. But we'll focus on GET and POST. There are two different types. These are two different types of HTTP requests. GET, as the name implies, is to get information from the server. So in the last example, all those would be GET requests. Hey, give me the HTML. Hey, give me the CSS. Hey, give me the JavaScript. POST is when you want to send information. I'm getting ahead of my slide here. POST is when you want to send information to a website. This is typically anytime you fill out a form. In most cases these days, technically you don't have to. In most cases, that form, when you click submit, is going to fire off a POST request. This is, hey server, here's some information for you. And then our servers are going to take that POST request, read the content of that, read the information, and then process it, do whatever we're going to do with that information that the user sent to us. So GET, give me some information. POST, here's some information. Like login, type your username and password, it's going to be a POST request. HTTP uses URLs, one of the many protocols that uses URLs. A URL, these you've seen before. How much you've actually thought about these is probably going to vary widely. But let's talk about them a bit. A URL is composed of these pieces, a protocol. What protocol are we using to send, to request this information? The host, it was localhost in our example. This could be a domain name, buffalo.edu, CSE312.com. Host, then :port. If you leave off the port, the default port number of your protocol is going to be used. So if you fire off an HTTP request, and you don't specify your port, you're using port 80. If you use HTTPS and you don't specify a port, you're using port 443. And then /path, this is the specific resource being requested. Then the query string and the fragment are both optional. Kind of the path is optional, I guess. In my example, I didn't specify a path. If you don't specify a path, the path is just / or the root path. The query string and fragment are both optional. These are if you want to send extra information to the server through the URL directly. For most cases in this class, we're going to have other means to send extra information to the server. We're not going to use fragment at all, and I haven't decided if I want to cut query strings completely either. Neither of them really serve a great educational purpose in this class, but so this might be the only time you see them. But this is how we add extra information. A query string is going to be a set of key value pairs. Once you see a question mark, and then everything after that is going to be the query string until a hashtag. and their key value pairs separated by the plus sign, and then the key and value are separated by an an ampersand. I'm like, that doesn't sound right. An ampersand. Key value pairs are separated by ampersands, and the key and value are separated by equal signs. So here we have two key value pairs, Q with the value web development, and then IA with the value images. Is going to make a DuckDuckGo search for the query web development, and we want images of web development. That's what's, if you do an image search on DuckDuckGo and you type web development into the search box and you click go, it's actually going to send this URL, a request for this URL to the server. And after you make a search, you can click the URL. The browsers these days shorten your URLs, but if you click on it, you can see the full URL, and you can see the URL that was constructed for your specific search as a GET request. And fragment is to specify some navigation on the page itself. If it exists, if a hashtag exists, that denotes the start of the fragment. And it can navigate to a specific portion of a page. Like if you want to link to some, I recommend, like we're not going to use this in 3.12, but I recommend you use these in your regular lives, like your daily lives. It can be helpful. Like if you want to send somebody a Wikipedia link, but you only want to send them like the 5th section, like down the page, and you send them the page and you say, just scroll down to the, what do I do in my example? Just scroll down to the definition section. That's where I want you to go. Well, if you use a fragment, it'll just scroll down to the definition section when the page loads. It'll go immediately down there. And you can do this with a lot of things. You want to send a 100-page PDF to somebody, and it's the information on page 45 that's relevant. Do a fragment. I forget the exact syntax. I think it's hashtag page 45. I forget the exact syntax. But you can send a fragment, which will scroll to that page of the PDF. It's really useful stuff. Just not something we'll use necessarily in 3.12. We won't code it on the server side. HTTP is stateless. That request response, that's it. That's all we get. On the other side, that's all you have to code. So when you get a request for some HTML, you don't make a note, okay, this user requested the HTML, they're probably going to request the CSS later. No. Later on, you get a request for the CSS, and you serve the CSS. You don't even care that that was the same person. HTTP as a protocol does not care. It's just request response. You get 5 requests from the same user. It might as well be 5 requests from 5 different users. Your server doesn't care. You don't have to code up, okay, this user is loading up the page. They're going to need all this stuff. Let me gather it all and send it all to them. No. It's up to them to make multiple requests, and it's up to the browser to piece all that content together to form the actual website, the web page. When we do want state, we'll talk about cookies. That's not for quite a while in this course. New lines, as we saw in the example code, new lines are /r/n. Is it annoying? Sure. Is it a fact of life? Yes. We have to live with it. This is yeah. I don't think I missed anything. This is just a fact of life. The HTTP protocol, this is how new line characters are encoded. Usually we don't like thinking about new line characters too much, but with HTTP we have to, because it's /r/n instead of just /n. What this comes from is back in the days of typewriters. It's kind of a relic of the old days, kind of a reminder that the internet is actually pretty old. It just became popular, well, before you were born, I guess. But so to you, it's been around forever. But it's from the days of typewriters. A carriage return. When you have a typewriter, you have the carriage going across the typewriter. Carriage return means get that carriage back to where it belongs, back to the start of the line. And then new line means rotate the thing so the carriage is looking at the next line of the paper. So it's a very mechanical thing. That's the old days of where this comes from. Carriage return, go back to the start of the line, and then new line, go on to the next line. We usually call this a CRLF, which I like to say CRLF because it rolls off the tongue a lot better than /r/n, which I stumble over all the time, which is the carriage return line feed instead of a new line. So carriage return line feed, CRLF. Just means new line character, but encoded with 2 bytes, /r/n. You need to be aware of that, as critically important. Everything will break. This is one of the common, not so much these days because I stress it so much in lecture now, but it was one of the very common first couple of weeks office hours questions, Piazza questions. Why won't this work? Well, it's because you have /ns and /r/n. CRLF, you have to have them. Have to have them. On both sides, too. You're going to get them in the requests that you read and the responses that you send. So when you're parsing requests, make sure you expect CRLFs. When you send responses, make sure you send them with CRLFs. Which takes us to our first GET request. You saw in the example at the beginning of lecture, the request that was sent was pretty bulky. There was a lot of stuff here. So let's trim that down to a minimal example and talk about this example as our first GET request. But when a client sends us a request, a GET request, it's going to be in this format. So let's break this down and talk about it. And specifically, it's actually going to look like this with the CRLFs. And notice that there's going to be 2 CRLFs at the end of a GET request. That will be really important when you're doing the code. That's a common cause of a bug that we'll talk about. So there is a blank line at the end of the request. So I'm going to show CRLFs just as new lines in the slides, just so it's visually better for us to see. But there is a blank line at the end. So there's a CRLF right here, and then a blank line right here with a CRLF right here. There's a blank line at the end of your GET request. I'll leave it at that for now. That'll come up again, though. If it doesn't by the end of this lecture, where are all my clocks? If it doesn't come up by the end of the lecture, let me know, because it's got to come up. So the first line of any HTTP request is going to look like this. It's going to be 3 values separated by 2 spaces. So it's going to be a value, which is going to be the request type, or the method, which is either going to be get, post, put, delete, head. I can't even think of all of them off the top of my head. Those are the 4 that we're going to use in homework 1. And get and post are 2 that we're going to focus on now. But anyway, the very first value is the method, the HTTP method, in this case get, then a space, and then the path, which is more than just the path. Path is a little bit misleading. If you have query string or fragment, those are also going to be in here. This is where you're going to read the query string and fragment, if I have you do those in any homeworks. This is where they'll show up. So anything after the port number, or if you're using the default port, anything after the host of the URL, it's going to go right here. And then a space, and then the HTTP version, which you can always assume is HTTP 1.1 for this class. I'm not going to use any other HTTP version. There are cooler versions out there. I say cooler, but for our purposes, they're not that interesting for the course. They're all just designed to speed things up. They're for efficiency, not for functionality. We want to focus on functionality in this course. Efficiency only occasionally when it comes up. Not the kind of efficiency that the other protocols are giving us, though. So since these are separated by spaces, your code is going to read this first line before the first CRLF. Split on spaces is a safe operation because the HTTP, the RFC, says these are split by spaces. And then read these 3 values, or rather these 2 values, because for our purposes, we can just assume the HTTP version. But you can read these 2 values. What's the request type and what's the path? This implies that you cannot have spaces in paths, which you probably all know intuitively. You can't have like a space in the middle of a domain name. This is one of the reasons why it would break everybody's parsers, because we're all parsing based on those 2 spaces. So no spaces in any URLs. If we have more path, like if we say cse312.com/lecture27.pdf, the additional text for the path, that part of the URL, is going to go right there. / is just the request for the root directory, which is usually where you're going to serve your HTML. And by convention, usually we serve index.html there. If you've made a web page, you've probably made a file called index.html. That's kind of standard across the industry, but it's by no means required. There's no magic there. It's not part of any protocols. It's just like that's kind of what we call our base HTML document. You can call it whatever you want, though. You can host anything at your root path. Next come our headers. There was no space in, so the HTTP/1.1, there's no spaces in that, if that's what you're asking. And there's no trailing space. There's right after the second one is the CRLF. And host has a space. That's what I'm about to talk about, though. So the request line, that's always the first line of your requests that you're going to receive, and you're going to be parsing these things. After that is any number of headers, each on their own line. So we have the request line, a CRLF, and then any number of header, CRLF, header, CRLF, header, CRLF. This example only has one header, so I want to keep the first example simple. And each header line is going to be a key value pair with the name of the header and the value of the header separated by a colon and an optional space. There might be a space after the colon, and there might not be. The protocol, the RFC says there can be, there can't be, it doesn't matter. So browsers and any client, it's up to them. They can do whatever they want. They can add that space there. They cannot add that space. Either way is fine. So if there is a space there, it isn't meaningful. A header value cannot begin with a space. So if there is a space there, your code should ignore it. So the common thing to do, split on colon, or not even split on colon, but find the first colon, and everything after that's the value, and then trim any leading white space from that value. That's how you would get the actual value of a header. Anything before the first colon is the name. And then when we get one of these requests, we parse it, we gather all the information that's in that request. We're going to send a response, which is going to be in a very similar structure as a request. Requests and responses are very similarly structured. Thankfully, it's less stuff we have to remember. So this is our first sample response, or more accurately, it's going to look like this with the CRLFs in there. These are the actual bytes that are going to be sent. But again, I'm going to show the CRLFs as new lines visually in the slide, just so we're not staring at this the whole time. But while we have the white space shown here, just to note, there is no CRLF at the end of this response, this one specifically. So first we start with the status line. This looks similar to the request line, except a little bit different information, different order. Start with the HTTP version, always going to be HTTP 1.1 for our purposes. A space, a response code, a space, and then the response message, or called the reason phrase in the documentation. The response code is telling the browser or whatever client, whatever software needs to know kind of what happened with this response. And the response code, or the response message, the status message or response phrase, that's the human readable version, which can actually deviate from protocol. It's just for humans to read. The browser's going to display that to its human and not really care about what it says. It's only going to look at the response code and handle things differently based on that response code. This is just for us humans. The code, if it's a 200, they're separated by level of code. The 200 level codes mean everything went well. 200 is probably the most common response code, but it's also one you'll never see unless you're a developer. So you've had billions of, maybe not billions, but a lot of 200 responses in your life. Pretty much anytime you're looking at a website and actually being delivered the content of that website, those are 200 responses. 300 means we're redirecting the user. These you get a lot too, but you don't see because things are just working the way they're supposed to be working, redirecting to another page. 400 level, we get into the codes that you're probably familiar with. The 404, not found, 403, forbidden. These are client errors, means something went wrong and it was the client's fault. And the scary 500 level errors, the ones that give me nightmares, these are something went wrong and it was the server's fault. It's the backend's fault, and this is when you got to wake up in the middle of the night and fix your app because things are going down and it's stressful. 500 level errors are always, I shouldn't say always, but most always bad. Yeah.
There's no 100 level codes?
Yeah, I was thinking that as soon as the slide came up, I'm like, why didn't I put 100 level codes? 100 level codes are, is it more than just this, but switching protocols is the one that we use, 101 response. Is there a general category of it, or is it always just switching protocols? Do you know? No, I forget. The only one I've used is 101 switching protocols, which we will use in homework 3. I didn't know if you were asking, like, are there 100 level, or there are 100 levels, I'm going to show him. Sometimes students do that, so I always got to be on guard. And then headers. Headers have the same exact format as request headers. You're going to separate your key and value by a colon and separate different headers by CRLFs. Your headers have to at least include these two headers, content type and content length, whenever you're sending content. And spoilers is going to be the same for post requests when we're receiving content, where there's going to be content type and content length headers. Content type tells us how to parse this thing, or tells the browser how to parse it. For this, we're just sending plain text. We're going to do content type text plain. And content length is the number of bytes in the body of the response. Hello is exactly 5 bytes, so our content length is 5. That has to be the exact number of bytes, or things break. The browser will take this as ground truth, so it has to be correct. Then CRLF separates your headers from the body, and then the actual content that you're sending. We have a couple different response codes we want to talk about. Right in Objective 1, the learning Objective 1 on the homework, there's 3 different response codes you want to use. 200, we covered. 404, not found. You've seen this all over the internet. 404, not found. You just put a 404 there, and then not found. It's something to note. You can have spaces in the code, the response codes. The browsers will look for the first 2 spaces and everything after the second space. That's how the browsers are going to parse these. Everything after the second space is going to be the response code, which can include, or not the response code, response phrase, which can include spaces. So not space found is valid here. Not true for requests where there can only be 2 spaces in the request line. So 404 not found is the same thing as 200 from our perspective. We're going to send not found. We're going to send some message, usually some HTML of some funny 404 page with monkeys or whatever. Funny things that developers do on their pages. But same format as a 200 response. Content length has to match the number of bytes of the content, and hit them with the 404 up here. I'm just doing plain text. We'll learn about hosting HTML and other stuff on Monday. And 301, the last response code I want to talk about, this is where that CRLF at the end does matter a whole bunch. If you're sending a 301 response, this is a redirect. For your homework, you have to have a redirect path that redirects to your other path that you write for Objective 1. 301 means this path doesn't exist, just go to the other one. When you send a 301, you have to have a location header, and that location header is going to specify where you're redirecting the user to. This can be either a relative path, in this case. Oh, this is my all relative. Relative path, in this case, new path will be the same host and port and protocol. Or it can be a full URL and give the absolute path. You can redirect someone to another page. Have a content length of 0 on these 301s. Technically, this shouldn't happen, and I swear this is Firefox's bug to deal with. But to avoid issues with Firefox, put content length of 0, or else Firefox hangs on your redirects. And the last thing I want to say here, since there is no body of your response for 301, your 301 still does have to end with CRLF. You have to have that blank line. Even though the body is 0 bytes, there's nothing after the CRLF, that has to be there. Just like the requests, the GET requests you get, that CRLF is at the end of the headers, it has to be there. It has to be there or else parsing breaks down. Post request is in the same format as the responses you sent. Content length, content type will be there, and the body separated by CRLF, CRLF. Whew. We'll get there with a minute left for the lecture question. Have a great weekend. I'll see y'all Monday, and stay warm out there.